In this video, we're going to work on the ALEKS problem called drawing a skeletal structure from a simple condensed structure. This problem is going to give us a condensed structure and it wants us to represent that molecule in skeletal or line structure notation. So to do this, as you know, we are going to not draw any of the carbon atoms. We're not going to show any hydrogen atoms that have been bonded to carbons. We're just going to use straight lines to represent carbon-carbon bonds. I'm going to number the carbon atoms as I draw this molecule in line structure from carbon number 1 to carbon number 2. The single bond, that's just a straight line. I'm not showing any of the carbons. I'm not showing the hydrogens on the carbons. From carbon 2 to carbon 3, that's going to be a double bond, so I'm going to draw 2 lines. From carbon 3 to carbon 4, single bond, 1 line. Carbon 4 to carbon 5, double bond, 2 lines. And carbon 5 to carbon 6, that's another single bond. To actually draw this in ALEKS, it's pretty easy. You're just going to click on this drawing tool and then just start dragging with your cursor, and it's going to draw the molecule for you. Nice and easy. When I went to actually do this in ALEKS, not this particular molecule, but a different one, ALEKS got a little bit weird. So let's take a look at ALEKS. It's got some quirks with this. Let's see what we need to do to make ALEKS happy. So this is a different molecule. It's got some heteroatoms, some oxygens on it. And this is where things get a little bit weird with ALEKS. So I'm going to start just drawing in my carbons. There's my 3 carbons, and then there's the CH3 group coming off the top of that. And then on that CH on the right-hand side, I've got 2 oxygens that are attached to that. Sorry, this moves around a lot because I'm on an iPad, like that. And I need to add right here, I need to add an oxygen, so it's an OH like that. And down here, I need to add another oxygen, an OH. And the way that I'm doing this, the way that I'm adding these atoms is just by tapping on the place where I want the heteroatom to go, and that opens up this menu and it allows me to pick what I want, looking like that. Now this, I think, is okay. I think ALEKS is going to like this. Yeah, let's see what I get next. Ooh, this one, maybe it will be okay, maybe it won't be okay. So I'm going to start by drawing, I've got 4 carbons in a row. I've got a double bond to an oxygen atom. Let's put an oxygen up there. I've got a methyl on that 3rd carbon over. Got another double bond to an oxygen, like that. Got a nitrogen right here and a couple of methyls. And I think ALEKS is going to like this as well. The problem that I was running into when I was working on these problems is I was trying to put an OH group specifically on the left-hand side of the molecule, like that. I typed it in like that. I hit check, and ALEKS said it was wrong, and it wasn't wrong. The molecule that I had did have an OH group on the left-hand side of the molecule, just like this. Keep in mind, that's not what this molecule is like. So I didn't understand why ALEKS kept marking it wrong. And then I realized down here on the bottom, ALEKS allows us to toggle the order of these atoms that we're adding from left to right and right to left. When you are putting one of these substituents, those functional groups, on the left-hand side of a molecule, you need to make sure that it is oriented properly. So it doesn't want the hydrogen to be on the right-hand side or to be aiming into the molecule. It wants it the other way around, where the hydrogen, looks like I can't even do it anymore, where the hydrogen is on the outer portion of the molecule, pointing to the left. If we were over on the right-hand side of the molecule, it wouldn't like this either. It doesn't want the hydrogen sticking in. It wants the hydrogens sticking out like that. I'm going to delete these because that is not what this molecule actually is. Yes, and this one, I was wondering if it would mark this one wrong as well. So this one, my guess is that it is wrong because of that methyl group, the way that I have it oriented, sticking up kind of ugly like that. I think that it probably wants the methyl group to be pointing down, looking all nice and symmetrical and pretty. Let's see if it likes this. Yeah, so this is a really quirky problem. It really wants the structure to be drawn in a way that is pretty. You've got to keep that in mind as you're working on this problem. Let's try one more, see if I can make ALEKS happy. There's my oxygen, there's a CH. This CH has got an OH on it, and we do not want to stick it up because it doesn't like that. There's another oxygen right there, CH2, CH3. I think this is going to make ALEKS happy. I think ALEKS would not be happy if I stuck the OH group up like this. I think it really wants all of these bonds to be spread out. So we'll delete that. Wants it down here, like that. I don't know, it doesn't like this one either. And I don't know why. Let's try reversing that OH group. See if it likes that. Oh my goodness. It is picky. Okay, go one more try. CH3, double bond to an oxygen, CH, CH3, CH, CH3, OH. This has got to make ALEKS happy. Look at how pretty that molecule is.